Okay, thank you so much for giving me this chance to speak about this topic today. And first of all, I would like to wish all of you a warm good afternoon. So, today I'll be talking about boosting climate resilience through conservation agriculture, insights from agricultural extension. So before starting my talk, I would like to introduce myself. Currently, I am working as a young professional in the G20 Agricultural Working Group, International Cooperation Division of Ministry of Agriculture and Farmers Welfare. And besides this, I have done my PhD with subject specialization of agricultural extension and communication, being an SRF holder from GB Pant University of Agriculture and Technology. So we all know the present era is facing a number of challenges in the post-green revolution era, which are the climate changes, variation in the climate, the nutrient deficiencies in our soil, reducing of the biodiversity, that is flora and fauna, declining of the factor productivity, building up of the pest infestants because of monocropping, then increased subsoil compaction, then receding water table, which is a major issues in the agricultural fields as well as in other urban areas also nowadays. And like adding up to this, there is environmental pollution. And all these challenges, they somehow are leading towards a declining soil health. And these are impacting soil health, which then impacts the crop production and crop productivity as well. So, in the post-green revolution era, when per capita income is rising and there is urbanization and globalization, we all are facing the challenges of a little bit food security and the challenges of giving healthy and nutritious food to all. And now we see in the storm, which is a perfect storm for the present agriculture, we need a paradigm shift in the whole agricultural system so that we can move towards sustainability and we can meet the food demands for our future generation. So as I already mentioned, apart from these problems, other problems are the problems of salinization, then loss of soil organic matter, then nutrient mining, and all these are the reasons of continuous intensive tillage, which is a very important factor of the conventional agriculture. That is, which is ongoing practices for the farmers since long back. So, as we all know, I don't know whether you can see this slide. I will just make this slide normal. So, how our ongoing conventional agriculture is a problem for all of us. So basically our ongoing conventional agriculture, it is an intensive tillage based systems, and this intensive tillage based agricultural systems, these are leading to some detrimental problems in soil, which are first of one is soil erosion, next the second is destruction of the soil structure, then declining in the soil productivity, accelerated decomposition of the soil organic matter, then it is too much labor intensive, as we all know, because for tillage we have to hire laborers, and in many parts of India during the cropping cycle we see there is a shortage of labor and other human manpower. So these are some problems. Then other problem of the conventional agricultural system is that is it is mainly monocropping based systems, where we cultivate only one or two crops in a rotation. And what leads and what is the result of this monocropping? This system becomes very much susceptible for pest and weed infestation, and these pests and weeds, they become resistant to our pesticides, insecticides which farmers are giving in a conventional mode. So we have to bring a change in this system also. And the third is, now we can see for like past few 3 or 5 years we are listening about the rising problem of residue burning, mainly in the northeastern region of India and especially in the states of Punjab and Haryana. And the major reason is there is this rice residue which these farmers are burning before cultivation of wheat, and this is leading to like environmental pollution and several other problems also. This residue burning, it also causes loss of soil organic matter and loss of nutrients also, which you can see has been mentioned in this slide also. So what is the next step? So we have to rethink and realign our policies, and we have to think towards a more climate sensitive and climate smart agriculture. The need of the hour is we have to make our agricultural system more climate resilient by helping farmers to build a resilient to adapt to the climate changes. Then the second point is sustainably increasing the agricultural production, since we all know that our global population is increasing like in a spiral manner. And the third one is reducing the greenhouse gases as much as possible in terms of a country or internationally. So what is the next step ahead? Our answer is conservation agriculture. It is not only the one-way solution, it is only a type of, like we can say, climate smart approach which we can adopt to lessen the greenhouse gas emission or to tackle the problems of conventional agricultural system. So coming to this conservation agriculture, we have to know first of all that what is it. So according to Food and Agricultural Organization, they have defined this conservation agriculture term, and this is mainly a ecosystem based farming system approach which helps in managing the agro ecosystems and improving its sustainability, its production and productivity, in terms of giving profits to the farmers and attaining the food security. So this conservation agriculture, or in Hindi we tell it Sangrakshit Kheti. So this terminology is not new. It is earlier we have heard the term about zero tillage or minimal tillage. This concept was introduced in 1990s, and then now after that we have come to this conservation agriculture, which includes three major principles which I will be discussing later. So why this conservation agriculture? So let's have a look in this slide where you can see this conservation agriculture. By practicing this conservation agriculture, we can raise our system yield to 5 to 10%. Then we can reduce our labor requirement by 26 to 44%. We can reduce the carbon dioxide reduction by 11 to 16%. We can save our energy by 46 to 62%. Then practicing conservation agriculture will increase the profitability of farmers by 16 to 56%. And last but not the least, the irrigation water requirement, it is also being lowered in this conservation agriculture practicing mode. Here it reduces by 8 to 17%. So coming to the principles of conservation agriculture, it is mainly based on three principles. So one by one I will discuss. First principle is minimal tillage. We can also call it reduced tillage or sometimes zero tillage. So what is this minimal tillage? As we all know, since years back we are practicing that before cropping or showing any crop, we have to till our land and then show it. But here in these conservation agriculture practices, our tillage, the numbers of tillage are reduced, or sometimes we don't till also. Farmers don't till also. So this is the concept of minimal tillage. So what happens when we reduce the number of tillage or we don't till at all? First of all, it is very obvious that our labor requirement it reduces, and since we don't use machineries also, so our fuel consumption it also lowers down. And the third is like this, from this burning of fuel there was carbon dioxide emission which was leading to greenhouse gas emissions from the fields and leading to this global warming. So like not in a big manner, but to some extent by adopting these conservation agriculture practices, we can reduce the contribution of agriculture towards greenhouse gas emission. So for this first principle, This minimal tillage, it avoids soil compaction. What happens in conventional tillage? Due to continuous tilling of the land, there is a hard pan formation under the soil. So since years back we are tilling, and if there is a hard pan formation, gradually it affects our crop yield and then crop productivity also. The second important part of this minimal tillage is it reduces the erosion. Sometimes because of continuous tilling, it causes erosion, soil erosion, because our soil particles, it becomes loose and all. So if we leave the land as it is, then there is a chance of reducing the erosion. The third one is, as I already told, it lowers the greenhouse gas emission. And the fourth one is it improves the soil fertility and soil structure. So in intensive agriculture, tillage based agriculture, due to formation of a pan, the soil fertility was affected and soil structures was not proper. So by leaving the land as it is after cultivation of a crop, like in a rice wheat cropping system, if I give you an example, then it will obviously help to improve the soil structure, soil aggregates, and then improve the fertility as a end result. Now, the second principle on which conservation agriculture is based, it is crop residue retention. That is, after a crop is being harvested, don't just take off the residues of your own field or just burn it. It makes the proper usage of the residue. It talks about keeping the residue in your own farm, and it helps to maintain the soil temperature. And how? Because these residues, they are acting as a mulch over the soil. So as we all know, that there is a now we can face variation in our weather and climatic conditions, like severe variations, and sometimes the temperature rises so high that our crop yields is not that much proper. So what happens when we maintain this residue on the field as it is? It makes a cover over the soil, it acts as a mulch, and it maintains the soil temperature. Next one is it improves the water infiltration capacity of the soil. Keeping the residues over the soil, it helps your better water infiltration capacity, and our soil becomes more fertile and more healthy. Third is it checks the water loss. And fourth is, because of keeping this residue, it improves the soil flora and fauna, because after keeping the residue, we see a number of microorganisms, they grow there, and they mix and with their biological properties, they make our soil more fertile and more adaptive, more what I can say, that more appropriate for cultivating a crop. The third principle of conservation agriculture is crop rotation. So now what is it? We all know this is crop rotation or intercropping. We can also say it that. So one thing is that in if we adopt this principle of conservation agriculture, it reduces the chances of crop failure and the economic loss due to if sometimes because of this irregular weather conditions of high heat, extreme heat, or heavy spells during the cropping season. If some farmer means his one crop don't yield that much, then crop rotation practice will help him to manage that risk. Then second point is it lowers the climate risk, as I already mentioned. The third point is in monocropping, as I already told, there is an increased susceptibility for the pest and weed infestation. Then by introducing different kind of crops in a cropping system, it can reduce the disease and pest infestation. And the last one is it allows to balance the residue production. So based on these three principles, minimal tillage, residue retention, and crop rotation, our conservation agriculture practices is based. Now coming to the next slide. So in Indian conditions, let us see what all initiatives have been taken by the government for promoting these conservation agriculture practices. So first one is CRP project on conservation agriculture. It is a consortium research project. It is a project by Indian Council of Agricultural research, and it is mainly for mainstreaming the conservation agriculture for sustainable use of land and management of the natural resources so that we can increase our yield and productivity. And like you can see, I have already mentioned in this like slide that under this project there are 10 ICR institutions which are working in a collaborative mode to promote conservation agriculture in India. And there is also another scheme which is not directly affecting the uptake of conservation agricultural practices, but indirectly it is helping a lot to promote this conservation agriculture practices, that is central sector scheme for promoting agricultural mechanization for in situ management of crop residue. Here the term in situ management of crop residue, and this all we know is a principle of conservation agriculture, and how then we can relate how this scheme is indirectly helping in promoting conservation agriculture. So this scheme also, by promoting farm machineries, especially like happy seeder, which is mainly meant for conservation agricultural practices, and happy seeder is that kind of instrument which can sow the seed when you are having your residues on the field condition as it is. So these schemes they are given on a renting basis to the farmers or farming community in individual basis or in a group mode, so that they can take these machines and go for this conservation agricultural practices. And means not like this, we can see in the IPCC report, recent IPCC report in 2019, they have also mentioned this conservation agricultural practices as one of the incremental adaptation methods to mitigate the climate risks. And what are its advantages? So the plus points are, they are paying a lot of ecosystem services. The first one being carbon sequestration, that is they are conserving carbon, and which is very much important in today's agricultural world. The second one is it prevents the surface erosion. The third is enhanced water infiltration, and then improving soil fertility and curbing the fuel use. Now see, this is basically from my research outcomes, what I have seen from the farming community, that how conservation agriculture helps in boosting the climate resilience. And here some benefits of conservation agriculture are being mapped, what farmers perceived. So you can see here, I'm just making this slide a little bigger. So these two lines, there are two dimensions. So one dimension, that is the horizontal line, it shows from more beneficial to less beneficial, and the vertical line, it shows the upper portion shows the environmental benefits and the lower portion shows the economic benefits. And here you can see there are a number of bubbles which are colored in different colors, and the shape of the bubble varies. So here the main thing is the bubble with the bigger shape, it is having higher importance, and in which column they are lying, we can understand that. So what farmer perceive, because as we all know, mainly in India, conservation agriculture is being practiced in the Indo-Gangetic stretch of India, that is including the states of Punjab, Haryana, UP, Bihar, West Bengal, and now it has also been started sporadically in other regions of India, northern India and southern India as well. But the major stretch for practicing conservation agriculture is this Indo-Gangetic plain. And so here the farmers perceive that soil health is an environmental benefits that conservation gives, like improvement in the soil health. And in this green color you can see, I'll just make this slide, like it is the fuel saving, that is the most important economical benefit, and the second one is time saving. So how this time saving is being achieved, like as I said, in conservation agriculture we don't till the land. So in a rice wheat cropping system, what happens after rice is being harvested, its residues are kept as it is on the field, on the farmer's field only, and then using a happy seeder, a farmer shows the next crop seeds, that is wheat seeds. So, in case of traditional tillage based cultivation, what happened? They first used to cut the rice, then the residues, they used to maintain these residues by any means, either by burning or by moving them, like any means. Mainly in northwestern India, they used to burn it, and then they used to keep the land fallow. And after a duration, it takes a duration of almost 30 days, and after that, they can show their wheat. So sometimes what happened in this case, the date of sowing of wheat was being delayed by 10 to 15 days when they were practicing the traditional mode of sowing wheat. But in case of conservation agriculture, since they can sow wheat in the residue based soil only, so it saves the time of 10 to 15 days, and they can sow their wheat on time. Now, we will see the global uptake of this conservation agriculture across the world. And here I have also mentioned the fact in India also. So, in globally, the conservation agriculture is being practiced in 205 million hectare land, and among the countries, it's the USA, Brazil, and Argentina, which are the top three countries which are practicing this conservation agricultural practices. And apart from these countries, it is being widely practiced in the countries like Australia, Canada, Russia, China, India, Paraguay. And in the south and in the southeastern Asian region, we can see India is a major hub of practicing this conservation agricultural practices. And in India, it's 2.5 million hectare cropping area which is under conservation agriculture. And according to a recent report by CEEW 2021 report, it says that approximately 1 million farmers in India, they are now practicing conservation agriculture, like partially or fully. Partially means they are not adopting all the three principles, any one or two principles they are adopting, and completely means they are adopting all the three principles of conservation agriculture. But still, we can see out of the total agricultural land of India, there is only 2.5 hectare of land which is being cultivated, and in southern India also it is being practiced sporadically. Now the question comes, why? That in spite of having this much of benefits, why the adoption is still sluggish, or why the adoption is still low? So there are some barriers or some constraints which are pulling back the free-fledged adoption of conservation agriculture. So coming to these barriers one by one, the first one is social barrier. So what this social barrier talks about, it talks about that if a farmer is being practicing conservation agriculture, which is very different from the conventional tillage, so he may feel that he may be left out of his farming community, or sometimes he feels a peer pressure that is, don't go for this conservation agriculture. So what is the reality? In reality, when I went to the fields and I talked with the farmers, they have told me that they were practicing conservation agriculture. That is, they were not tilling the land during the daytime. But what happened, because of the peer pressure at the night time, or some of their relatives, they used to till the land at night, and then it didn't follow the principle of conservation agriculture. So there comes a big social barrier in the way of adoption of conservation agriculture. Now the second point is, and which is the most major thing, that is the psychological barriers. Because from the first slide I am talking about this. So let me explain this. So what happens? Changing a certain mindset of people is not a really easy job, because since years back people were practicing this tillage based agriculture or tillage based cropping system practices. But all of a sudden, we are coming from scientists and researchers, they are coming with some new sort of approaches, paradigm shift, for bringing about paradigm shift in agriculture. And we are talking about adopting minimal tillage or reduced tillage approach. And so there is a striking difference between what they were practicing and what the scientists and researchers are saying. So accepting this thing, it takes much more time, and this needs a total or complete behavioral change in the farmers, that is to go for minimal tillage based cultivation. And in this case we can see our old age farmer or middle aged farmer, these are the section of the farming community who are not ready to accept these conservation agricultural practices on a easy go. We can convince and we can tell or educate our younger generation of the farming community that what are the advantages or good effects of practicing conservation agriculture. So making this mental shift is the need of the hour. The third one is institutional barriers. And in these institutional barriers, we will be talking about lack of infrastructures and lack of collaboration between different institutes. In India, talking about conservation agriculture, I think I missed two names. That is, first one is CIMIT, International Center, International Center for Research on Maize and Wheat. This is the CG Institute, and the second one is Bolog Institute for South Asia, that is BISA. These two organizations are working very hard to promote or to facilitate the adoption of conservation agriculture in India. So only these two? Other organizations should also come up with this. And in reality, when I went to the field, I went to Western UP also. So in that region, what I found, the small and marginal farmers, they have not even heard about the name of conservation agriculture. So there is something lagging, and like from lagging from the institutional part, because we need a convergence and linkages among the different institutes at different levels, that is at national level, district level, and then at village level. Then only we can spread the information properly. It's not like that one or two organizations or only 10 institutes of ICA, they are collaborating and converging, and we can promote this conservation agriculture in a holistic manner. So institutional convergence and linkage is a must thing for promoting this conservation agriculture. The third is financial barriers, because this happy seeder is a new thing, and then for harvesting of the products which are being shown by conservation agriculture, or for harvesting for the rice fields, rice also in a rice field cropping system, we need a combined harvester with a SMS straw management system attached with it. And as we know all, in India, majority of the farmers are small and marginal, and they can't afford that much. So making it available for the farmers in a custom hiring basis, and like improving the financial, like giving incentivizing the farmers whosoever are adopting these conservation agriculture practices is also needed. Then the fifth one is the technical barriers. Sometimes different types of technical barriers, like the lack of inputs are not properly given, because sometimes if the farmer can't get this happy seeder on time for showing, what they do, they will cultivate their seed and they will show in a conventional way. And mainly the small and marginal farmers, they are the victims who are not getting these instruments on time. Then the lack of instruments, then difficulty in repairing the instruments. So these all comes under the technical barriers why conservation agriculture is not widely adopted. And the fourth most is environmental or agronomical barriers. Because sometimes we see, in case of conservation agriculture, farmers from the fields, they have reported there is infestation of rodents, especially rats. So what happens, since we are like keeping the residues as it is in the field for conservation agriculture, so in some parts of India, they are facing the mice infestation or rat infestation, which are affecting the next crops also. So this is a major problem of conservation agriculture. And second one is, there is a problem of higher weed infestation, since farmers are telling that we are not tilling the soil. So sometimes what happens, these weed seeds are being retained in the field, and the weed problem is much more in terms of conservation agriculture, adopting conservation agriculture practices. So these are all the barriers which are practically affecting the adoption of conservation agriculture. Now coming to my part, being specialization in agricultural extension, that what role extension can play. Because as we all know, regarding this conservation agriculture topic, it is not like that one single discipline like soil science or agronomy, people from those disciplines can go for it. There should be a multidisciplinary or team based approach, so that we can ensure the farmers regarding the good effects or beneficial effects of conservation agriculture, and here extension plays the role at the last part. So the first one is disseminating the right information at the right time. So many cases and many researchers, they have reported that the nutrient use in case of conservation agriculture is not properly known to the farmers. And not only the nutrient use, the irrigation scheduling also. In a rice wheat cropping system, like in wheat, which is conventionally shown, we normally know that the first time of irrigation is 21 days after sowing, that is crown root initiation stage. But some researchers say in case of conservation agriculture, we have to give the first irrigation at 30 days after sowing. Okay, so there are some like this kind of minor things which farmers are lacking or don't know, and it is the role of the extension to disseminate them the right information at the right time. And the second most important thing is that India is a diversified country with different types of agroecological systems, and the land type, soil type is different from North India to South India, from Eastern India to Western India. So, one size fits all approach will not be appropriate to improve the adoption of conservation agriculture. We have to stick out to the principles which I mentioned for the conservation agriculture practices, but it has to be site specific. People or farming community have to modify it according to their own agroecological conditions or according to their own soil type, and then vary it. And even now some researchers have, they have also developed some conservation agriculture specific rice or wheat varieties, which farmers can again check whether in their region these varieties are giving good yields, good results or not. So like this, our all approaches have has had to be site specific, so that people or farming community, they can adopt it in their own way. The next one is establishments of the knowledge hub at the village level. At the village level itself, we have to create or establish a knowledge hub from where the farmers of that particular region can gain the idea that what to do when they want to adopt this conservation agriculture practices. The third most important thing, since we are making a big transition in terms of shifting from tillage based agriculture to no till agriculture, we have to incentivize the farmer and educate the farmer about savings of carbon and how this conservation agriculture it helps in lowering the greenhouse gas emission. So not only intensifying the farmers in terms of a particular principle, we have to incentivize the whole system in terms of giving carbon credits, and thus we can motivate the farmers to go for this kind of practices. Then, as I already told, conducting awareness programs for the farmers. The next one is uh, capacity building, or we know training the farmers regarding the packages and practices of CA. Many of the farmers, they don't know how to operate these happy seeders, or those who are small and marginal farmers. We have to arrange these machineries on a rental basis for them and have to train them that how to use these machineries or how to sow seeds in a residue retained conditions, by giving timely training, like we can give it on a fortnightly basis, on a monthly basis, or prior to any cropping season. Then this kind of activities from agricultural extension will obviously help to boost up the adoption of conservation agriculture practices. The next one is expanding the scope of application of CA principles to other pulse-based crops also. So now in India, majorly we are practicing this conservation agriculture on the cereals-based cropping systems. So if we are shifting it to the pulse-based cropping system, seeing its site specificity or what it requires, then for many other farmers also, like pulse growing farmers or small farmers also, then they will be easy to adopt these conservation agriculture practices. The most important one is collaboration and convergence of research and extension institutes of both the public and private sector. Not only public sector itself can do everything, it's the role of private sectors also to come into this play and hold the hand with the public sector to make the inputs available at a low cost to the farmers. And the last is implementation of policies on CA, especially targeting the small and marginal farmers, since they make the major portion of farming community in India. So educating them first, and then we can educate the other farmers also, because small and marginal farmers are they are vulnerable to any kind of risks in the agricultural system. So we have to give support to them, incentivize them, and motivate them at the priority, and then we can move to the big or medium farmers. So, in a conclusion or in a nutshell, to sum up my topic, that is boosting climate resilience from the conservation through conservation agriculture practices, a perspective or insight from agricultural extension. So, we know here you can see in this slide there are three bubbles, and the center portion it tells about adoption of conservation agriculture. So, adoption of any climate specific approach, may it be conservation agriculture, may it be organic farming or natural farming, it requires, first thing is proper knowledge, the second one is a change in the attitude from the existing one, and the third is making using the knowledge, changing the attitude, bringing the change in our behavior. And if we can bring a change in our behavior, then it will lead to the adoption of conservation agriculture in this particular case. And here you can see in blue I have given some pushing factors, that is the beneficial effects of conservation agriculture. First one is ecological, environmental, economical, and enhancing the sustainability of the farmers as well as farming system as a whole. But in all cases there will be some pooling factors, barriers, or like hurdles, which are like financial hurdles, social, psychological, institutional, and biophysical. So we have to overlook them, and we have to implement the site specific, target specific, need based strategies. We have to realign our strategies on the basis of that, and then we can achieve a full-fledged adoption of any new practice or any new technology. And what to say about this behavioral change in the behavioral intention here, a constant nudge to the farmer is most essential. So by that way we can educate or make a behavioral change or shift in the mind, bring a shift in the mind of the farmers, and make them aware of the new technologies like conservation agriculture, and make our farming system more climate resilient. So in conclusion I want to say, if conservation of natural resources goes wrong, then nothing else will go right, because our everything is based on these natural resources. If soil is not healthy, then our production can't go better. Thank you. Hello. Hello.
Thank you, Ms. Tanishta, for a detailed presentation.
Okay, thank you.
Take up the questions. Just 1 second.
Yeah.
Okay, so the first question is, how can conservation agriculture contribute to climate resilience in farming practices?
Okay, so as I already told, Like there are three principles of conservation agriculture. The first one is minimal tillage. And what happens when we minimally till our land? Our We don't use any kind of tillage instruments, okay, like tilling machineries. So in that case, we can cut down the fuel use and fuel consumption and fuel burning, which lowers the greenhouse gas emission from the field. And second one is that for that minimal tillage, our soil, like the soil surface or soil subsurface, earlier there was a hard pan submission, and because of continuous tilling, the nutrient loss was also more. So we can help in conserving the nutrients, and like we can stop the emission of like nitrous oxides or different kinds of oxides from the soil. So the first principle of conservation agriculture, that is minimal tillage, it only talks about lowering the greenhouse gas emission and making it more this approach more adaptable or more climate resilient in a farming system.
Okay. And what are the key principles of conservation agriculture that farmers should adopt?
So what I think, crop rotation, as I told, there are mainly three principles. First one is minimal or reduced tillage. The second one is crop residue retention, and third one is crop rotation. So I think in India, in many cases, like in northern or southern India, people are following intercropping or crop rotation. So this is the principle which by since years they are doing it. So apart from this, what they have to do, they have to lower their tillage or reduce the tillage. I'm not saying that don't do any tillage, because this principle says minimal tillage. So they have to adopt this minimal tillage condition. And obviously, first of all, they have to see that what kind of crops they are adopting or they are trying to grow. So this is the main thing. And the third one is which the farmers of North India means sometimes follow or sometimes don't follow, that is the crop residue retention. I already told that in many times people what they do, just farmers they themselves are telling that it's easy to like burn a residue rather than like waiting for the machine to come, and then they will show the next crop seeds. So residue retention activity, that is one thing that farmers they have to try adopting. And when they will be adopting all these principles simultaneously in one way or other, they are practicing this conservation agriculture.
Okay. And how can agricultural extension services support farmers in implementing conservation agriculture practices?
Okay, so extension support is the very important thing which is needed at the last hour, because research what is being researchers are being coming from soil or agronomic specialists, and then it's the role of agricultural extension to disseminate them and bring a behavioral change in the farmers so that they can actually adopt that practice in their farms in reality. So agriculture extension first, that is establishment of knowledge hubs at village level. Okay, so and that hub should disseminate that region specific information to the farmers only, because I already told India is a diversified country with different agroecological systems. So one size fits all approach will not go good with all these things. It have to be tailored for all the different regions. So extension personnel, first of all, do they have to collect this tailored information for different agroecological zones, and they have to establish village hubs, and then disseminate information at the right time, that is prior to cropping system. Then the second thing is that what they can do for motivating the farmers, they can incentivize them in terms of carbon credit, because conservation agriculture directly or indirectly it is leading to carbon sequestration. So incentivizing the farmers who all are practicing conservation agriculture as a whole, then it can obviously motivate them. This is one role of extension. Then the third part is capacity building. that is how to use these machineries, that is conservation agriculture specific machineries like happy seeder, combined harvester with straw management system, the machineries which work on residues, so they can give a training to them, they can give a training on the nutrient scheduling or irrigation scheduling in case of conservation agriculture. And third and last but not the least, they have to link among themselves, both the private and public participants, they have to collaborate and they have to converge at some point to bring about behavioral changes. And the other most important thing, after certain days they have to give a nudge to the farmers so that farmers can be reminded of these agricultural practices.
Okay. And what are the benefits of conservation agriculture for farmers term in terms of
Okay.
climate resilience and productivity?
Okay, so one best example which I can cite to you, that is now we know that is our rainfalls are very irregular. Sometimes, in case of a rice wheat cropping system, like at the end of wheat season, like when it's almost the time to harvest, when farmers are practicing normal or traditional tillage based wheat cultivation, what happens if sometimes it rains heavily during that last hour, all the crop yield and crop production gets affected. The plants lodge and they lodge down, and the quality of grains or production it lowers, and means it affects the productivity severely. But farmers, when I went to the fields of Punjab and Haryana during my research, and after that also in several parts of UP where it is being practiced, what farmers themselves told, that is, in case of conservation agricultural practices, when they are keeping their sowing their wheat on a residue based field, and when it rains at the last hour, those wheats, they are not getting affected, the lodging down is very much less, and they give a good quality and good yield. So this is how this system is making it more resilient to climate, to the vagaries of the climate change. The first thing is that. The second thing is that another most important technique which is being used for conservation agriculture is laser land leveler, which is used for leveling the land. And when our land is leveled, it lowers down the greenhouse gas emission. So this is the second point, that how this conservation agriculture is making our system more resilient. And third point is it helps in carbon sequestration, which is also making it more climate means making the climate system more resistant to handle the shocks of climate change.
Okay. And what are some practical strategies that farmers can use to conserve soil moisture and prevent erosion?
Okay, so some practical strategies might be, means if they are not following all the principles, they can follow the principle of crop residue retention. That residue will act as a mulch, and it will obviously help in conserving the moisture, maintaining the soil temperature, enhancing the soil biodiversity, and most of all, it will prevent the soil from eroding.
Okay. And um, how can conservation agriculture help farmers adapt to changing weather patterns and climate variability?
Okay, I think I have mentioned this. This can help. The first one is by preventing lodging at the latter stage of wheat production, as I already mentioned. Then reducing the greenhouse gas. Then scoring for carbons when it comes to saving of carbons. And now we all are talking about carbon sequestration, carbon saving. So by this, they are also helping the farmers to tackle or adapt to the climate changes and changes in the weather. And then the another most important point, because of this extreme heat or dry spells, sometimes different kinds of pests they are being seen. But in case of conservation agriculture, when we are doing crop rotation and in a crop rotation manner, when we are using the pesticides, these kind of pests, they do not get the resistant to become they don't get resistant to the insecticides, and they don't stay long for a longer time. So these are the ways.
Okay. And what are the potential challenges or barriers that farmers may face when adopting conservation agriculture practices?
Okay, so first barrier that farmers will face is obviously small and marginal farmers they will face, because what happens in practicality, we know there are now in India, in several parts of India, custom hiring centers are being started, and they are giving machineries on rent. And when we talk about these happy seeders or combined harvesters, there is a long list of farmers who are in the queue for getting these machineries on rent and then using it, since they are trying to go for conservation agriculture. But when it comes to small and marginal farmers, they are in the last row of this queue, who are means these farmers get the last chance, means first big farmers will get, because it's also that big farmers can pay the rent and get it done within some days, because they are also having other facilities also. So marginal farmers and small farmers are the main section of the farming community who will be affected because of this scenario. And another important barrier for them is a transition in their mindset, because their established mindset is like tilling the land and getting a good result, good yield. So believing the fact that without tillage or reducing the tillage can give you a good yield is next to impossible for them. So making a behavioral shift or change in the mindset and shifting, modulating the attitude is the need of the hour. Then the third important thing is sometimes they get peer pressure, or they fear of being excluded from the farming community. And sometimes, as I told, that the problems of rats and infestation, it also comes into means farmers also can see, because of this crop residue retention, sometimes rats come and they destroy the yield or something. So these are some sort of practical challenges, but these are not those challenges which can't be tackled. Obviously, I have told mentioned the strategies how farmers can handle this.
Okay. And how can agri entrepreneurs integrate conservation agriculture into their business models and contribute
No,
to
no.
climate
Yeah.
resilience?
So this is most important. What I was talking about, it's not only the public sector, it's the role of public private, and we can means approach for a PPP model. And here, agripreneurs, what they can do, the inputs which are specific to conservation agriculture, or like these machineries. So entrepreneurs can if somebody starts any entrepreneur, they have their startup of the machineries, agro machineries, what they can do, they can make the machineries, or they can purchase these machineries, conservation agriculture specific machineries like happy seeder, and they can give it to rent it to farmers, or directly sell it to farmers. In this way they can make their position in this model, in this like adoption model of conservation agriculture. Not only these based on this agro machinery, entrepreneurs they can also what I can say, this consultancy based entrepreneurship, they can give the nutrient scheduling or irrigation scheduling patterns, proper irrigation scheduling patterns, and region based cropping practices and all to the farmers in time. And in this way they can make a move.
Okay. Now we have the last question.
Mhm.
Are there any success stories or case studies of farmers or agri entrepreneurs who have implemented this and seen positive results in terms of climate resilience?
Yes, of course. So one case study is of a farmer. His name is Vikas Chaudhary, and he is a big farmer from the Karauri district of Karnal, and whom I have personally visited also. Means like he himself told that his father earlier he was not ready to accept these conservation agriculture practices, because he was of the mindset that how minimal tillage or zero tillage can give you a good yield. But his son, when he adopted this, because their success story is like that, Simit had taken this initiative, and in the earlier years Simit went there, told them to form an FPO, and if they form FPO, then Simit will fund them or help them and bear the risk for first few years, and they can see the results, and if they are being satisfied with the results, then they can increase and grow with them. And he is a farmer, I think, who has been practicing these conservation agriculture practices since 2011. It's almost like 12 years back when he started, and now he's a very renowned farmer. Everyone can get his name and get his success stories in the websites of Simit also. Vikas Chaudhary, he is Vikas Chaudhary, Mr. Vikas Chaudhary, and he has given several talks on it, in different national and international forums also. He went abroad also to share his success stories, and now he is a rice wheat, mainly rice wheat cropping system, and now he is having like nursery for rice, for raising like rice plants also. So he practices his everything in a conservation agriculture mode, minimal tillage, crop residue retention. And he himself told that there are different told me that there are certain specific pesticides or insecticides which can curate all the problems of, because of what other farmers are telling, that they are receiving because of this pest infestation and all. So yes, there is a man, Vikas Chaudhary ji.
Okay, that's good to know.
Hmm.
Okay, Dr. Tanishta, I don't see any more questions from our participants. So now we have come to end of question round. On
Okay.
behalf of agricultureinformation.com, we like to thank you for the detailed presentation and answering all the questions in depth. And we
Hmm.
also like to thank all the participants for joining this meeting. The meeting will now be closed.
Okay. Thank you so much.
You're most welcome. Thank you.
Hmm. Hmm.